Hi and welcome to this lesson on equal and opposite forces. So write today's date and title and then we'll get on. Right, your starter is to label the forces on these diagrams. So pause the video and either copy the diagrams or print off the sheet that I put on fronter and then add the labels. Okay, so we're going to start with the car and you should have labelled the weight acting downwards. Then acting upwards, we have something called the normal contact force, which we talked about last lesson. That's the force that stops two objects from passing into each other. We might also have thrust, moving it forwards. And then opposite to the thrust, we'd have the drag or the friction or the air resistance. Okay, so drag is the general word for any force that slows something down. Friction is between two solids. Air resistance is between solid and air. Okay, if we look at the boat, again, we've got the weight acting downwards on it. And this time the force acting upwards is called the upthrust. That's the force that you get upwards in water that stops things sinking. Then you may again have some thrust for pushing it forwards and some drag or air resistance pulling it back. Okay, if we take a look at the yo-yo, again, you should have labelled weight acting downwards. And upwards, we've got the tension in the string. Okay, for our rocket, starting again with weight acting downwards. Then we've got the thrust going forwards. And air resistance is acting in the opposite direction to the direction it's moving in. Okay, so if you've got all of those, we're going to move on to the other drawings that were on the sheet. So again, either sketch it out or on the sheet, draw your diagrams and add the forces on there. Pause the video while you're doing that. Okay, so for our monkey, we've got weight acting downwards, and then the force keeping it upwards is the tension in the monkey's tail. Then for our cactus, we've got the weight acting downwards, and what's stopping it going through the table? It's that normal contact force again. Okay, so that leads us on to Newton's third law. Newton's third law, you might have heard of, says every action has an equal and opposite reaction. So for example, if the Earth's gravity is pulling me down with a force of 700 Newton, then my gravity pulls the Earth up with a force of 700 Newtons. You can see that they are both the same type of force. For an equal and opposite pair, the force type always has to be the same, but they are acting on different things. So the Earth's gravity pulling me down is equal and opposite to my gravity pulling the Earth up. It's switching which way round the force is going. And then you'll see that they are equal in size. Both of them are 700 Newtons. But they are opposite in direction. So the Earth's pulling me down, I'm pulling the Earth up. Okay, so that's where the equal and opposite comes from. The equal in size, but opposite in direction. Let's have a look at that in a particular scenario. So we've got a book on a table on the floor. Again, I've put the sheet on fronter, or pause the video and sketch it out. Okay, so we're going to label up what the forces are acting on each thing. We'll start with the book. The book has weight acting downwards on it, the gravity from the Earth and from the table. And there is a normal contact force acting upwards on it. Okay, that's what's stopping it from falling into the table. Now that's not our equal and opposite force pair, because they're different types of forces. Right, if we look at the table, we know that the table has a weight pulling it downwards. That's due to the gravitational pull of the Earth. We also know that there is a normal contact force acting on the legs of that table that stop it passing into the ground. And again, these are not equal and opposite force pairs because they're different types of forces. Now, where we do have an equal and opposite force pair is because we've got a normal contact force from the table on the book, we also have to have a normal contact force from the book on the table, and so that pushes the table downwards. We've also got a very small amount of the gravity from the book pulling the table upwards. Okay, that's equal and opposite to some of the table's gravity pulling the book down. And then the forces on the ground. Well, because we've got a normal contact force from the ground onto the table, there is a normal contact force from the table onto the ground. And then we've also got the gravity from the book and the table pulling the ground upwards. Now, we don't see the ground moving upwards because the earth is so heavy, but it's still there. Right, so why is this useful? Well, first of all, let's just think again about the normal contact force. Whenever two objects touch, there is a force acting between them at right angles to the surface of the object. That's called the normal contact force, and it's the force that stops two objects moving into each other. Now, how this is useful is it enables friction to cause movement. Okay, if we were swimming, for example, when we're swimming, we push the water back. That's the friction between us and the water pushing the water back, so the water then pushes us forward. If we think about how we walk, let's have a look at how that looks in terms of the foot motion. So, as the foot moves, the foot pushes backwards on the earth, and that causes the earth to push forwards on the foot, and that enables us to move forwards. Right, so can you complete this P.E.E? Your point is that without friction, we wouldn't be able to walk. Can you add the evidence and the explanation for that? I've got some prompts there to give you a hand. You can draw a diagram if it helps you explain your answer, and you will need to upload that as your evidence work from this lesson. So pause the video while you do that. Okay, and we're going to finish off by looking at this exam question. The diagram shows a boat pulling a water skier. The arrow represents the force on the water produced by the engine propeller, which causes the boat to move. Explain why. So pause and have a go at that, using that knowledge about equal and opposite forces from today. And then we'll have a look at the answers. Okay, so the first mark is for saying that there is a force from the water onto the boat. So because we've got the boat putting a force on the water puts an equal and opposite force on the boat. And because it's opposite, it's in the forward direction or in the opposite direction. Okay, any questions? Just let me know.